All right, in section 4, we're going to solve quadratic equations. And basically, anything that's got an x squared in it is a quadratic. And then it's an equation because we have equals. And then over here, we have a 0. It could be a number, but we would always move it over to the left side so that this side would have equals 0. Now, let me say before we get into the various methods that this is going to be kind of a review of all the different methods of solving quadratics. This will give you examples of each method, but in truth, you need to look at what's in the book and maybe practice a number of examples. I'm not going to give you so much homework that you have to practice, but you might want to practice on your own so that you can do these more easily. And part of it really is just recognizing the different types of problem and how we can solve them. Now, the first thing we want to do is always look for, is there any common factor? Like, for instance, with what we have here, if we had a 2 and a 14 and a 20, all those numbers are divisible by 2, so we could factor out that 2. But if not, what we want to look for is it factorable? In other words, it's kind of doing backwards of what we were doing in the last section about multiplying two binomials together. In other words, if I start here and I go x times x, well, that gives me the x squared. X times the negative 5, well, that gives me negative 5x. Negative 2 times the x, that gives me another negative 2x. Together, that's negative 7x. And then negative 2 and the negative 5, well, that gives me the positive 10. And so before, multiplying these two would give me this. In reverse, this can be factored into those two pieces. And then once we have those, we can then set each one of these equal to 0 because the basic problem is equals 0. And then the x minus 2 equals 0 will give us x equal 2. And the x minus 5 equals 0 will give us the x equals 5. Now, only a limited number of problems can be done this way, and so this is not the only thing that we'll be learning, but it is one of the ways to look for. It's maybe the simplest kind of form that the answer can have. Basically, two numbers, especially two whole numbers. Now, sometimes we will see something that has only two terms in it, like here, x squared minus 25, which it turns out we have a name for. It's called the difference of two squares. And the difference of two squares automatically factors into basically x plus 5, x minus 5. So note the first ones are the first one square rooted. X squared square rooted is x. And the second number is the second one square rooted. Square root of 25 is 5, but one's positive and one's negative. And if you think back to our last section, this is kind of like those complex conjugates in which the middle portions got canceled out and just left us with the sum of the two squares. This is a difference of two squares because there's no I involved here, so we don't change the sign. Likewise here, 4x squared minus 9y squared. Again, the square root of 4x squared is 2x, so the first part of each one is 2x. The square root of 9y squared is 3y. The second part of each one is 3y, but one's plus and one's minus. Or in general, a squared minus b squared equals a plus b and a minus b. Now, there are other formulas, if you will, that work with just two terms. There can be the difference of two cubes, which is this one here. A cubed minus b cubed equals a minus b times a squared plus ab plus b squared. And there's a sum of two cubes, which is a plus b, and then a squared minus ab plus b squared. Note how similar these two are. And one way to keep them straight is if it's a cubed minus b cubed, the first term is a minus b. If it's a cubed plus b cubed, first term is a plus b. And then the second term has an opposite sign for the middle term. So negative here, positive there. Third term is always positive. Positive here, negative here. Third term is always positive. Now, that second part, which is a quadratic, since it's got an a squared or b squared, depending on what those represent, is not factorable. This is usually as far as we can get in terms of nice factors. Now, sometimes quadratic equations can be solved by extracting square roots. In other words, if we had something that was like this, x squared equals 49, we could simply just go square root of both sides, and that will lead to answers that are plus 7 and minus 7. Notice I got both of them, plus 7 and the negative 7, because of course negative 7 times negative 7 is a positive 49, just as positive 7 times positive 7 is a 49. Another way of thinking about this is if I had moved the 49 over to the other side, I would have had something that looks like this up here, x squared minus 49 equals 0, and that would have left me with that difference of two squares, which would give me the same result. I do not have to have both sides actually be squares. So in other words, x squared equals 48. 48 is not a square. But if you remember from before, 48, I could do two factors, 16 times 3. The 16 is a square. The 3 is not, so I can change it into 4 root 3 and negative 4 root 3. And that would give me two answers. Now, I will tell you, for things like this, it really does help if you know your squares up to about 10. Likewise, you could use your calculator and take the square root of a number, and if it doesn't come out evenly, you know it's not a square. That's another way that can be used. All right, now, those are kind of things that are pretty straightforward from stuff that we've already looked at. We're going to get into some other varieties now. First, complete the square. Let's suppose we started with something like this. Now, by the way, I can tell that this is not factorable right off the bat because, in fact, the numbers that would give me a 2, well, there's only two, 1 and 2, and there's no way to add a 1 and a 2 and get a 4. So I know it cannot be solved by factoring. But I can do a process that's called completing the square. And pretty much here's how it goes. The first thing I do is I take the part that doesn't have any x with it. So notice x squared minus 4x plus 2. And I move that to the other side. So notice that it's on the right side now. Then what I do is I look at the number in front of the x term, not the x squared, but the x term. Divide it into square and then add to both sides. So a half of 4 is 2. 2 squared is 4. So here I've added 4 to both sides. Now I have something on the left that is a square. In fact, it is x minus 2 squared. On the right, I have negative 2 plus 4, which of course is 2. Note that I now have this set up very similar to what I was talking about in the previous paragraph, x squared equals 49. Yes, it's x minus 2 quantity squared equals 2, but it's a similar form. I can take the square root of both sides. So on the left, it's just x minus 2, whatever is inside the parentheses. On the right, plus or minus square root of 2. And then all I need to do is move the negative 2 to the other side. And so x is 2 plus or minus square root of 2. So one of my answers is 2 plus square root of 2. Another one is 2 minus square root of 2. I can check all of these by plugging it back into my original equation. So there was my original equation, x squared minus 4x plus 2. Put in the 2 plus root 2. Go ahead and go through the math, and as long as I get 0 equals 0, everything works. Again, to complete the square, first move the x squared term and the x term to the left side, and anything that's not got an x to the right side. So these are on the left side, that's on the right side. For the second step, take the number in front of the x term, cut it in half, square it, add it to both sides. In this example, the x term was negative 4x. The negative 4 was cut in half, which is negative 2. Negative 2 squared is 4. We added 4 to both sides. The left side is now a square. X squared minus 4x plus 4 equals x minus 2 squared. If you took x minus 2 times x minus 2, this is what you would get. And then after simplifying the right side, which had the negative 2 plus 4, we ended up with this, and then we take the square root of both sides. Now, we can generalize completing the square to a form in which we have ax squared plus bx plus c, where a, b, and c are all real numbers. And it turns out we can derive a formula. And you've probably heard of this formula, even if you do not remember what it is. And it's called the quadratic formula, in which x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We simply plug in the a, b, and c wherever we see them, and then simplify. So for example, if we had x squared plus 5x plus 6, which it turns out is factorable, but we're just going to pretend it's not, because the quadratic formula will work every time, even when it's not factorable. Nothing in front of the x squared means it's a 1. We don't always write the 1s. 5x, so the b is 5, c is 6. Plug them in the various spots that we're supposed to, and then simplify, and we ended up with negative 5 plus or minus 1 all over 2, which gives us two answers, negative 2 and negative 3. And by the way, anytime we do the quadratic and it comes out with nice numbers like that, with no square roots, no i's or anything in it, then we know that the original equation could have been factored. Now, sometimes we don't want to go through all that work, and we want to know what kind of answer we will get from the quadratic formula without actually knowing what the specific answer is. It's kind of a quick and dirty approach to see if we're going to have any real answers or not, or if we're going to have square roots in our answers or such. And what we do is we find the discriminant, and the discriminant is d equals b squared minus 4ac, which is basically just what was inside the square root of the quadratic formula. So, turns out if d is negative and not a perfect square, then we get two complex solutions, which means we have i's and we also have square roots. On the other hand, if it's negative but it is a perfect square, we will get two complex solutions that have i's, but we won't have any square roots. So it'd be like 3 plus 2i and 3 minus 2i kind of things. If d is 0, then we only actually get one answer. We don't get two. Normally, we should get two from solving quadratic equations. If it's a positive perfect square, we'll get two rational solutions. Rational means does not contain square roots. By the way, irrational means it does contain square roots. But notice the positive ones do not give us the complex. They do not give us answers that have I in it. And then if it's a positive but not a perfect square, we have two irrational solutions. So, for example, 2x squared plus 2x plus 3 equals 0. So the d, again, d is just b squared minus 4ac. So b is 4. A is 2. C is 3. We plug those in. We end up with negative 20. Since we have a negative sign, we know we're going to have a complex solution, meaning that we're going to have an I. And since 20 is not a square, we're going to have a square root in our answer. On the other hand, x squared plus 5x plus 2 equals 0. When we plug all of that in, we get a 17, which is positive, so we don't have any i's in our answer. However, 17 is not a square, so we're going to get two real solutions that have square roots in them. So they'll be called irrational solutions. All right, so let us look at several of these kinds now. First off, I want to solve the following. I want to first look to see if I can factor. Basically, what I'm looking for here is two numbers, one positive and one negative, because I have a negative 32 here. Two numbers that when I multiply will give me 32, but when I add them will give me 14. Those two numbers are 16 and 2. Note that one is positive and one is negative. A quick shortcut is the bigger one will match the sign of the middle term. So since this is plus 14, I made the 16 the positive one. And I knew I had to have one of each because, again, the 16 times the negative 2 will give me my negative 32. Now you might say, well, I'm not going to know that it's 16 and 2. I might have tried 4 or 8 or something. And I'm like, yeah, that's fine. If you try a combination to get your third term, two numbers that multiply to give your third term, and it doesn't work to give you your middle term, then try another two terms. Now, once I factored it, I then set each one of these equal to 0. And then solve. So one of my answers is negative 16. The other answer is plus 2. And again, I could always check by plugging things back in. For instance, 2 squared, well, that'd be 4. 14 times 2, that would be 28. 4 and 28 is 32. 32 subtract 32, and there's my 0. Okay, here we have just two terms, one on each side. I could square root both sides. So 2x subtract 6 equals plus or minus. Got to do that plus or minus. The square root of 24. 24 has a square in it. Basically 4 times 6. And the square root of 4, of course, is 2. So I can simplify the root 24 into plus or minus 2 root 6. Now, move the 6 by adding 6 to both sides. Then dividing everybody by 2. Which means one of my answers is, and the other is, but it's easier just to write it with the plus or minus. All right, my third example, we're going to do a complete the square. I know it's not factorable because the factors for 1 are just 1 and 1. Well, that's not going to give me 10. The factors for x squared are just x and x. There's no way to get a 10 there as well, so I know it's not factorable. Let's do a complete the square. Complete the square is always going to work as well. So first, x squared plus 10x equals negative 1. Then x squared plus the 10x. Half of 10 is 5. 5 squared is 25. And so I have to do that to both sides. Add that 25 to both sides. On the left, I now have my square. Notice how the 5 is half of the 10. That's always the form it'll take. On the other side, I have 24. And now it looks very similar to what problem 2 did. I can take the square root of both sides. Which we've already done as plus or minus 2 root 6. And we're going to subtract the 5 from both sides. And that is our answer. Now, Number 4, we're also going to do a complete the square. It's a little bit messy though because of that 3 in front. So I'm going to start off the same way. However, I'm going to divide everybody by 3 now, so that this just has an x squared. And then I follow the same rules I had before. So half of this squared added to both sides. So first off, rewrite what's there. Now half of 8 over 3 is 8 over 6. 8 over 6 squared would be 64 over 36. And on this side, we are now going to have and then on the other side, this is 3. That's 36. I can't add fractions unless I have common denominators. So I'm going to need 12. 12 times 3 would be 36. Well, 12 times the 7 is 84. So this is actually negative 84. Which will give me negative 20. Now, note, I didn't change that into 4/3 for a reason, because I'm now going to square root both sides. So on this side, I'm going to have this. And on this side, I'm going to have plus or minus the square root of negative 20 over 6. Because, of course, the square root of 36 is 6. And so now they have the same kind of denominators again. Move the 8 over. Don't forget the negative sign. It's all over 6. Now 20 has a square in it, 4. So basically this is going to end up being 4i root 5. The negative sign gives me the I, 2i. Because I take the square root of 4 to give me the 2i. And then it's still all over 6. And my final answer is x equals, now I can divide, it's even. So I'm going to end up with 4 plus 4 minus I root 5 all over 3. And there is my answer. All right, now let's look at a couple of examples of doing a quadratic formula. And honestly, I really do think it helps. Go, A is 6, B is 7, C is negative 5. Actually write down the letters and what each one equals. Then use your quadratic formula to plug everything in. So let's see, we got x equals negative b, so that's negative 7 plus or minus 7 squared, okay, minus 4 times a times the c. Please note, that's a negative, that's another negative. Those are going to cancel and give me a positive and add. And then here, 2 times the 6. So this ends up being negative 7 plus or minus. Turns out everything in the middle there equals 169. And all of that is over 12. Now, not done, because I can take the square root of 169. Turns out that that is 13. So now I have negative 7 plus or minus 13. all over 12. And again, if you're like, well, I wouldn't know that 169 could be square rooted, hey, use your calculator. See if the square root of 169 equals something. So I will have negative 7 subtract 13, which would be negative 20 over 12, which is negative 5/3. And x for the other one will be negative 7 plus 13, which will be 6 over 12, which is 1/2. Now, it turns out, since both of these don't have any square roots, don't have any i's or anything, this, in fact, was factorable, even though at first glance it might not appear that way. All right, second example. Again, I'm going to use the quadratic formula. A equals 1, b equals negative 4, c equals 5. So x is going to equal 4, opposite of b. Negative 4 goes to 4, plus or minus. Okay, so the b squared, so that's 16. And then 4ac, so 4 times 1 times 5, that's 20. All over 2 times 1, so that's just 2. Well, this is going to give me 4 plus or minus the square root of negative 4 all over 2. And of course, the square root of 4 will be a 2. I, because of the negative sign, my final answer will be 2 plus or minus I, because the 4 over 2 will give me the 2, and the 2 over 2 will just give me the I. All right, in the next one, note I have fractions. So my first step, I get rid of fractions. I'm going to multiply everybody by 6. 3 and 2 both going to 6. So that'll now give me 2x squared. Subtract 6x plus 3 equals 0. So a is 2, b is negative 6, c is 3. Plugging those in, I'm going to get 6, opposite of negative 6, plus or minus square root of 6 squared, that's 36. Subtract 4ac, 4 times 2 times 3 is 24. All over 2 times 2 is 4. So I'm going to have x equals 6 plus or minus 12 over 4. 6 plus or minus 2 root 3. Took the 12, turned it into a 4 and a 3. Square root of 4 gives me the 2. 3 can't do anything with, so it stays in square root. Again, all over 4. Even, 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 so I can divide everybody by 2. So 3 plus square root of 3 plus or minus square root of 3 all over 2 for that one. All right, for number 8, let me rewrite it so that we have room. So this says first factor a difference of 2 cubes. Now the rule for a difference of 2 cubes, and on a quiz or test, you can use these. You don't have to have them memorized. That's my general form. Now, if you're not sure, you can always switch it out. So 27, it turns out, is 3 cubed. And of course, x cubed is x cubed. And 8 is 2 cubed. So my a is 3x in this case, and the b is 2. It would help, again, if you know your cubes. I would say up to 5 anyway. You don't really have to go past that. And again, you can use your calculator to help you on this. But now that I have my a and b, I can go ahead and factor it. So I'm going to have 3x subtract 2 as the first part. Then a squared, so 3x squared is 9x squared. And then ab, so 3x times 2 will be 6x. And then the last part, 2 times 2, will be 4. And then I still have the equal 0 part. All right, so I am not going to, this part's easy. Since it's already in a binomial form, I can just set it equal to 0, which means 3x equals 2, which means x equals 2/3. So I have one of 3 answers. With quadratics, a square power, I'm going to get 2 answers. With cubes, I should get 3 answers. All right, so for the second part, I'm going to go A is 9, B is 6, and C is 4. I'm not going to, in other words, I'm not going to try and see if I can factor it. I'm just going to go ahead and put those in because quadratic formula always works. So x equals -6 plus or minus 6 squared is 36 minus 4 times 9 times 4, which is 144. Again, 4 AC, so 4 times 9 times 4, and then it's all over 18, 2A, 2 times 9. So this is -6 plus or minus 36 minus 144 is -108. 108 is not a square, so this is not going to factor. All over 18, which is -6 plus or minus. Turns out 6, and then we still have it. In other words, my 108 equals 36 times 3. The 36 got square rooted into a 6. The 3 I couldn't do anything with. The negative sign is what gave me the I. 6 goes into all 3 of those, so I can divide everybody by 6. And there is my answer for that one. Yeah, sometimes these problems take a while. All right, in the last part, we want to use the determinant to find out what kind of solutions they would have. So, again, A is 4, B is -12, C is 9, D equals B squared minus 4AC. So this is going to be 144 subtract 4 times 4 times 9, which is 144 subtract 144, which is 0. So we have one factorable rational solution. Okay, in the second one, A equals 1, B equals -3, C equals -40. So D is going to equal 9 subtract 4 times 1 times -40. 4 times the -40 is -160. A negative sign makes it positive. We're going to end up with D is 169. That's a square, that's positive, so we have 2 rational solutions. And it's, again, was factorable. And by the way, when we say that, we mean no square roots, no i's. Now, by the way, since this one is 0, that means that we tended to end up with some kind of problem that was kind of like this. it was the same thing twice. So when we put each one equal to 0, they're going to give us the same result. Whereas this one, we're going to end up with two different factors, but again, no square roots, no i's. All right, our last one, a is 1, b is -4, c is 12. So our d will equal 16. Subtract 4 times 1 times 12. Again, 4 BAC, b squared minus 4ac. So 4 times 1 times 12 is 48. So we're going to get -32, which means 2 complex irrational solutions. Which means, first of all, it's not factorable, has square roots, has i's in the answer. Now, this is a lot of different methods for solving quadratic type equations. We can factor, we can take the square root of both sides, we can complete the square, and we can use the quadratic formula. You know, I'm not going to give you that many problems on homework, so you have to maybe do a little bit of practicing on your own so that when you have a quiz or a test, you kind of are familiar at least with where to start for each type of problem. And that does it for section 4.